The second part of chapter 1 is exploring the validity of conjectures. So for instance, if we look at this diagram below, we would say we might make the conjecture that all the lines are slanted. But are all the lines slanted? We should check to make sure that we can see the validity of the conjecture. All the lines are slanted, but are they? And what's a way that we could check to see if all the lines are slanted? Well, what I could do is I could take a ruler and I could measure in between each one of these lines from here all the way down to the bottom, from here all the way down to the bottom, and so on. And see, you know what? If I measure at the end and if I measure at the beginning, are they the same length? Is it the same distance between the lines at the end and at the beginning? That'll tell me if they're slanted or not. If it's the same length at the beginning and the end, this is one way that you could do it, then I can maybe make a conjecture that all the lines are parallel. And that might be a more valid statement. Again, it's a conjecture based on evidence. I've shown some evidence. I haven't proven it though, because I would have to take a kind of like an infinite number of lines everywhere to prove that it is never slanted, because maybe it slants in and then slants out again. But if I do just a couple things, I can actually prove or show, not prove per se, but I can show that my conjecture that each line are parallel, then it is true based on some evidence. Statements made on the basis of existing patterns, which we just saw above, supported by inductive reasoning, which we did some inductive reasoning, are called conjectures. Conjectures can be true, false, partly false, sometimes true, or sometimes false. In order for a conjecture or postulate to become a theorem, it must be proven. To prove a conjecture, one must state it in any given conditions or assumptions. One then makes a series of statements, each supported by a theorem, already proven or by a given statement. There's lots of examples of this in math, where you have, okay, every triangle, all the angles in the triangle add up to 180 degrees. Well, how do you know that? Well, we have other theorems that we've proven before that. The last statement is the conjecture, which is now a theorem. So after you prove or show that a whole bunch of patterns are true, we can say, oh, you know what? These lines are all parallel based on my knowledge that I can see that they do not slant. They're parallel, all the same distance at the front and the same distance at the back. We could look at this picture and we could say, you know what? Some of these lines are curved and some of them are zigzagged. But in fact, they're all curved. None of them are zigzagged. The only problem comes into play when you change the color. It's actually an optical illusion. So this continues on this pattern where it's curved, curved, curved. But when you switch the color, the dark part being on top, it looks far more curved than the dark part being on the slant. And again, you could take a piece of string, or you could prove this, or you could show this by taking a piece of string or something like that and showing that, you know what, they all have the exact same curve to them. It's just an optical illusion based on color. But again, you might make the conjecture, you know what, some of these lines are curved and then they change to zigzag, then they change to curved. But in fact, if you do some searching, you find some evidence, you'll see that they are in fact all curved. So that would be a conjecture based on your evidence. So hopefully that explains a little bit about, look at a given situation, try to figure out what a good conjecture might be, and gather some evidence to support that.